Fellow mathematicians, we're going to take a look at a problem involving the quotient rule with trig functions. And we're going to go through this in two ways. The first way will be a straightforward application of the quotient rule with divide and conquer. So let's go ahead and write down the numerator, f. That's going to be 1 minus cosine of x. And the denominator, g, that's going to be sine of x. All right, just be careful when calculating f prime. We know the derivative of cosine of x, that's negative sine of x, but there's a negative or minus in front. So let's be careful when calculating f prime. That's likely where a mistake would probably be made. The derivative of 1, that's a constant, that differentiates to 0. We're going to think of this as being a constant multiple, negative 1. And now, use parentheses, your derivative for cosine of x, that's negative sine of x. And we can rewrite that. Notice the negatives there, you're multiplying, those cancel to an addition, a positive, and we don't need the 0. So we can write f prime as just sine of x. Again, take your time there. That's probably where the first or maybe the only mistake is made. All right, now we need to calculate g prime, but the derivative of sine, that's just cosine. So that's straightforward. And now we just put our pieces back together. So our function was y. We'll be putting them back together to get y prime. And if we just combine our pieces, the first part we have f prime, which we simplified to just sine of x. So it's f prime times g, sine of x, times sine of x. And then minus f of x, use parentheses, 1 minus cosine of x. And that multiplies g prime, which is cosine of x. All right, and that's all over g squared, and we're just going to write that as sine squared of x. All right, now we can actually simplify this, and you should. In fact, the question might be worded in your Calc 1 course as calculate a derivative and simplify. So definitely try to do that. We can rewrite this as sine squared of x, but be careful here. We have a cosine of x. We're tempted to distribute that in, but we have a minus in front, a subtraction, with a minus inside. So let's take our time, and first, we're just going to distribute cosine of x into these parentheses. We're going to keep the minus in front there. Again, one of the best tips is take your time and try not to do too much all at once. So first terms, we'll rewrite them as sine squared of x. We have our subtraction, or minus. And now a set of parentheses, but we're just distributing cosine of x inside. So the first part, we're going to get cosine of x. And then multiply cosine of x by cosine of x. We'll rewrite that as cosine squared of x. And the denominator is still sine squared. Now we can simplify by taking that minus and distributing through the parentheses and changing all the signs inside. So it looks like what we get. We have sine squared still, sine squared of x. But now minus cosine of x. But the crucial step here, we now get plus cosine squared. The negatives cancel. And that's all over sine squared of x. Now this can be simplified further. You probably already know what we're going to do. We have squared trig functions. And we're going to make use of the Pythagorean identity. Sine squared of x plus cosine squared of x. That equals 1. So if we group those terms together, those two, sine squared plus cosine squared, we can rewrite that as 1. And what we're going to be left with is 1, and then the other part minus cosine of x. And that's all over our denominator, sine squared of x. So there we go, a straightforward application of the quotient rule with divide and conquer, and we took our time with simplifying it. Now, the second way that we're about to go through, we can actually rewrite this and apply different trig derivatives. Let's go ahead and get to that second part right now. Let's start by rewriting our function before we differentiate. Now we can do that here because our denominator contains a single term. So we'll just split this up using some basic results on fractions. We're going to rewrite this as 1 divided by sine of x and then minus cosine of x divided by sine of x. Now, this is going to be a good idea rewriting if you're comfortable with your basic trig identities. We can rewrite 1 over sine of x as cosecant x, and cosine divided by sine, that's cotangent of x. And what we have done here is taken a problem that was initially a fraction or quotient, we split it up, and at this point, we don't have to apply the quotient rule at all. Now, this is only going to be, again, a good idea if you're comfortable with these identities, and at this point, now the derivatives of cotangent and cosecant. Now, you should be comfortable with those. You should know all 6 trig functions and their derivatives, but I find sometimes even the best Calc 1 students sometimes struggle with memorizing the derivatives of cotangent and cosecant. They don't come up a lot, not nearly as much as derivatives of sine, cosine, tangent, and secant, but still know them. And that's the key here. So now this is how we're writing the function y. And now we just calculate the derivative. So I'll put that right below. And we're just going to differentiate each term. The derivative of cosecant, that's negative cosecant x times cotangent x. And just be careful, we know the derivative of cotangent has a negative. We're going to think of this minus as the constant multiple, -1. And we'll use a set of parentheses. So now, inside the parentheses, the derivative of cotangent x, that's going to be negative cosecant squared x. You might be comfortable simplifying your signs already, but I always like to do a little bit more work, so that way I don't make mistakes in my Calculus 1 course. It's also a good tip for you, students. So here we'll just rewrite that as a plus. Everything else stays the same, negative cosecant x times cotangent x, but now plus cosecant squared x. And that is our derivative here by first rewriting, which allows us to avoid applying the quotient rule. Now, between the 2 different ways that we went through this, they're both equivalent amounts of work in terms of space, but very different. The first way was very straightforward with the product rule, but a little tedious in simplifying it. And here, if you could look ahead to see that you could apply these identities, that might have been simpler for you. So it really just comes down to what you, as an individual student, are familiar with. Hope you enjoyed the problem. If you did, support the channel, like and subscribe.